Now children, I am going to explain next very important part, and it is the measurement of conductivity. You know, the conductivity is of two types, equivalent conductivity and molar conductivity. You have this previous knowledge, and so we'll see how to determine. Actually, children, this is measured, this is determined by indirect method. It is determined by indirect method. It cannot be measured directly, just like we measure resistance directly. How we measure resistance? We measure resistance by multimeter. You know, multimeter has two electrodes or probes, one negative, one is positive. So simply we connect, and so the resistance, it is given by the multimeter on the scale. But here it is measured indirectly. So we can say the conductivity of a solution can be measured by indirect method only. It can be measured by indirect method only, and it is measured by a special type of instrument. It is called as post office box. Previously it was called as post office box or Wheatstone bridge. It is in physics basically. So it is measured by post office box or Wheatstone bridge. It is very simple instrument. Post office box, because in earlier times, 30 years back, when the technology was not so advanced, the persons sitting in the post office, they were able to locate any fault in telephone lines or any telegraphic lines. You almost know telegram. In olden days, around 20 years back, telegram was very effective way. It was message was communicated at lightning speed by telegraph machines. So it is there, and it is very simple instrument. It has this type of diagrammatic arrangement. Here we have the resistances, and the three resistances, they are known. Let it be R1, this will be R2, this is R3. Now here on this there is a special type of vessel, because we have to see the conductivity measurement, and so this is the conductivity cell. This is the conductivity cell. This is conductivity cell, and conductivity cell, it has the electrodes. These are the electrodes of conductivity cell. These are the electrodes, platinum electrodes coated with platinum powder. It is coated with platinum powder, and this platinum powder is also called as black platinum powder. Black does not mean it is black in color. Ultimately divided platinum powder is called as black, because it is ultimate, finely divided. Why it is there? It is there to facilitate easy passage of current. Now see here. Here we have the again there is the supply of the current. This is the supply of current. Here we have the galvanometer. Let it be A, this is B, this is C, this is D. This contains here, this is the electrolyte. This is the electrolyte under observation. Electrolyte under observation means the electrolyte which has to be, taken for the experiment, or whose this conductivity has to be determined. So this is the diagrammatic arrangement. This is galvanometer. Now this is the current supply. This is the current supply. Now here the current is always AC. Here current supply is there. So here it is AC. Now question is, why we pass the AC current? The current supply is AC, but question is, why it is AC? Because children, when we pass DC current causes electrolysis of the solution. So here we have taken solution and there is the electrolysis, and what happens? On electrolysis, the water will undergo dissociation. It means it will be broken into hydrogen oxygen. So the concentration of water, the amount of water will be decreased, and the concentration of electrolyte will increase. And as a result, what will happen? The solution will become stronger with respect to time. Now simply, here it is unknown resistance. Here the electrolyte, let it be the X, and simple R1 upon R2 is equal to R3 upon R4. And so simple by this method, the value of Rx, it is unknown, so it can be find out. So this is the very simple way to find out the conductivity. Now furthermore, actually children, the electrolytic vessel, which is having fixed dimension, and this electrolytic vessel, it has platinum electrodes like this, and the platinum electrodes, they are coated, platinum electrodes coated with black platinum powder, and it contains the unknown electrolyte solution. Now the electrodes, platinum electrodes, they have fixed distance. The distance between the electrodes is fixed, and it is because the conductivity cells, they are designed in a very specific manner, very specific dimension, so as to have the standard protocols. And here the distance between the two, it is measured by distance L, and here they have fixed area, and so they have the fixed area. So this is the area S square. Why I'm writing? Because our purpose of this S square is the area of cross section, or the area of the conductivity plate, or area of the electrode under which the solution is present for the electrolysis. So there is other point about this. There is the cell constant. So cell constant is a point, and it is fixed for a particular conductivity cell. Now the cell constant, it is equal to L upon A. Cell constant is equal to L upon A, and its value is fixed for particular cell, because this is a standard quantity, and so like this. Now last part, this kappa conductance, it is equal to cell constant upon R, and this R, it is, it is X or it is unknown, and so by using this we are able to determine the any conductivity of any particular cell. Now last portion, this is the molar conductivity. So molar conductivity, this K, we use this term for the concentration. This is the volume, and so the formula Kv, 1000 upon M, molar strength of solution, equivalent conductivity, Kc into V, C for the equivalent concentration. So Kc 1000 upon Eq. Now coming to the units. So units here, So unit for this, it is equal to, Siemens centimeter square, mole inverse, Siemens centimeter square mole inverse, and here it is, it is equal to Siemens centimeter square per equivalent. So this is all about the measurement of conductivity and how we use, etc.